Introduce ma'am for yourself. Myself. Okay, ma'am.
Okay.
Thank you, ma'am.
Yes, sir.
Uh, uh, on good afternoon to one and a half here, person here. On of on behalf of Organizing Secretary, Department of Statistics, Bharathiar University, Coimbatore, and jointly associate this program, uh, PG and Research Department of Mathematics, Jamal College, Tiruchirappalli. This program is funding associate with DPT, Government of India. Today is the second session of day fourth. The last 3 days is grand successful of this program. Today the resource person, I glad to introduce the resource person, Dr. Ranjita Pandey, Assistant Professor, Department of Statistics, Bharathiar University. Ma'am is the completed BSc Max Statistics Economics from University of Allahabad, MA in Statistics from University Allahabad, PhD in Statistics University Allahabad, postdoctoral PGDCA from MCRP University of Bhopal, and French certificate from Patanjali Vidyapith, Rajasthan. The ma'am is the carrier of starting the program, professional experience of program, assistant professor, senior grade at from University of Delhi from 2050 to present. Previously, lecturer in permanent Patanjali Vidyapith from 2000 to 2005. The ma'am is the associate administrative assignment, member of DC, DRC, BRS, Faculty of Mathematical Science, MPhil Committee, Purchase Committee, Syllabus Revision Committee, for MSc Syllabus Revision Committee for BSc courses, Committee of Internal Assessment Test, NAC Committee, convener and co-convener of various subject committees under FIUP, Anti-EU Testing Committee, Committee of Course for Honors and Postgraduate Studies, Workload Committee, Committee for Drawing of Panel for Appointment of Assistant Professor in the colleges and Department on ad hoc basis, Admission Committee, Board of Moderated for various undergraduate and postgraduate courses, Internal Audit Committee, Coordinator of MPhil Committee, External Work, Nodal Officer of the Department of NAC Committee, Superintendent of various theory and practical examination of the department, Superintendent of conducting Department of MTS written exam, convener of committee, coordinate practical examination of various colleges, framing of syllabus, and many others of committee overs the years. The MAM is the area of interest and specialization, theoretical and applied based in inference, lifetime distribution, time series model, demography, imputation methods, ecological modeling. The MAM is the teaching of subjects, statistical methods, applied statistics, statistical inference at UG level, Bayesian inference, stochastic process, applied stochastic process, operational research, queuing theory, theory of reliability at PG levels, applied Bayesian statistics, research methodology, stochastic process at MPhil level, practical paper based on SPS, C, Excel, and MSc level. The MAM is the additional statistical paper following the Department of Delhi University, MPhil African Studies, MSc Geology, MSc Botany, and also the MS syllabus for framing the biostatistics course of department. Ma'am is the undergoing the PhD supervisor and mentor of several students. Is 2018-2017 of 2 students, and PhD is undergoing the process. MPhil is 5 is students is awarded under the guidance of Dr. Ranjita Pandey, and associate with the several faculty, morality, population density of reviewer of estimation of program, submitted the process, the monography. MPhil is undergoing the process. Ma'am is the publisher, the reputed journal of more than 200, post publication of book reviewer, information geometry and population genetics, the mathematical structure of the right Fisher model by Julian Hofreis, Jerfen Jost, and the Todd Taran Springer of 2017. The previous ma'am is the publisher the pre-publication of books, contributed new few questions and reviewer of based on the pre-publication Indian edition of book Pearson, the global edition of statistics, the art of the learning from the data, the Brahmaconic ISPS of functions. The publication of last
Sir,
2 years is shortly is there several. The ma'am is the
sir,
conference organization president. Ma'am, few minutes I completed, ma'am. Next, the ma'am is a research project of major and minor of projects. The associate with the professional body awards and the fellowship decisions of research fellows and other activities of the various academic programs. Now I request the today special address Dr. Ranjita Pandey, Assistant Professor, Department of Statistics, Bharathiar University, Coimbatore. Welcome you, ma'am.
thank you, sir, for
Thank
such
you
a
very much, ma'am.
nice introduction, sir. And
Okay,
thank
ma'am.
you for inviting me here at this platform where I can interact with all these young, budding, and uh, intelligent students. I'm very thankful that I am interacting across the state during this pandemic. Also, I can connect with you. So, thank you for inviting me to this platform. This was very short notice. So I decided, keeping in view the target group that we have, I was told we have students from mathematics and statistics and other areas, computer science. So, cutting across these different disciplines, in such a short notice, I decided to keep the talk very general, but each of you at the end of the talk will be intrigued to know more about this area. And I believe at the end of the talk, each of you will have some new learning, something new you will get to know. Right. So I thought since all the students are from the scientific disciplines, I will speak on scientific evidence today. Now, this evidence, I myself from mathematics statistics background, so this evidence, how we use for the reasoning in the mathematical areas, in the statistical areas, in the objective areas, right, where we do not incorporate any subject information, like everything is through the modeling or the symbols or the mathematical operators. So the incorporation and interpretation of this evidence in mathematical fields. Now see, learning is a very enjoyable experience. So is writing, of course. Now, I will speak about some scientific inferences and the surrounding controversies. So now what I'm focusing on are the controversies, right? Now, see, all of you must be sitting in some place there, wherever you are, some physical space. If you look around, right, you are just sitting inside a space. But if there were no walls around you, you would not be sitting there, would you? No, right? So you just look at this controversy where people are saying that I created the space for the student to sit. Right. But the space is already there, don't you think? The space was not created by the people who claim that they have. What was created was the walls around the space. The space was already there. So this is called controversy, looking into the finer argument. Such kind of evidences, numerous evidences, I will try to produce before you today. Right? So we call such inferences and such confusions around the controversial statements, we call them paradoxes. So what are paradoxes in mathematics? So I just wanted to ask you, sir, is my screen visible to the participants?
Yes, ma'am.
Okay, can each
However,
of
yeah, board
can
is there, ma'am.
okay. So all
Okay.
of them can see the whatever I am writing. Is that correct, sir?
Yes, ma'am.
Thank you, sir. Okay, so now we come back to the paradoxes. What is paradox? It is a kind of a statement. It is kind of a statement about a phenomena which is contradictory in nature, right? Whatever you feel in reality is not the truth. Something other, something else is truth. This is paradox. So what do you say is these are statements, but these are counterintuitive statements. Okay, so counterintuitive statements are paradoxes. Now, one statement I've already told you about the space. So nobody creates the space. Space is already there. No one has the potential, power, or capability to create the space. From today, remember this aspect. Okay, the finer thing inside the statement. What they will create is infrastructure around that space. So a true paradox, what is a true paradox? That will be a concise expression. That expression where somebody said, I created the space, it was not concise, remember. So it is a concise expression and that will give you a profound idea. Now all the students with whom I am interacting here on this platform, I believe each of you is a gem, right? So something from this talk, some idea from this talk, you will indeed pick up at the end of the talk, right? And of course, each of you will look at the same sentence differently. That is a human temperament. We interpret in a different way, right? Each of us, according to our own scientific temperament. So now I tell you, a true paradox will be a concise expression. And this expression will give one profound idea, right? So this paradox, it will provoke indisputably a very wild and endless imagination. But these are a source of creativity, right? So study of paradox, if you study them, it will lead to clarity, ultimate clarity, right? So I will elaborate on some findings from the statistical literature, right? We have to be, as scientists, very critical all the time and very open-minded, right? So I begin my talk now. With a statement. A man who fears suffering is already suffering from what he fears. Do you understand? I repeat, you can write if you feel like. A man, this is the opening line of my lecture, a man who fears suffering is already suffering from what he fears. So this is a paradox. He doesn't know it. He is fearing that I will be suffering. That is very fearful. But at present, he is already suffering from the idea of suffering in future. So this is a paradoxical statement, right? And different philosophers will write differently about it. Somebody can write even 200 pages on this aspect, right? So it is a philosophical view. A man who fears suffering is already suffering from what he fears. Now, there is another statement. I shut my eyes in order to see. The second paradoxical statement of today. I shut my eyes in order to see. Actually, function of eyes is vision, to see. But if you want to see something very clearly, normally what you do to focus, you shut your eyes. Again, this is a paradoxical statement, remember. So what I am saying is paradoxes are what? Counterintuitive statements. I hope I am making myself clear because I cannot ask you your response. I'll try to repeatedly speak on the same thing so that whatever I am trying to communicate drives home. Right? Now, probability, all of us know, is a measure of possibility. Right? Remember, probability is a measure, numeric measure of possibility. But does probability 0 mean impossibility? Third statement of today. Probability is a numeric measure of possibility. But if numeric probability is 0, does it mean that it is an impossible event? No. Only based on the observations and experiences so far, I'm assigning it a value 0. Something that has not happened till today. That has probability 0. COVID never occurred before, but now it has. So before 2019, the probability was 0, but today it is not so. So probabilities change. Okay. So third paradox, I repeat, probability is a numeric measure of possibility, but probability 0 does not mean impossibility. Okay. So even if I have a numeric measurement, I know it is a probabilistic statement. So it is not true for all times. It is true only for the so far observed or so far repeatable events. Right? Now, paradox of democracy. I will speak on paradox of democracy. A country can have national democracy, but at the same time, there are many countries we know which have democracy, but they are practicing dictatorship. Right? So, what they are doing is they are trying to make changes to democracy. Right? They are saying, they are propagating that democracy is good, but in their own country, they dictate everything to their own people. Right? So, this is the last paradox. In general, I wanted to introduce the idea of counterintuitive statements through these small sentences. The first scientific paradox that I want to take up with you is Simpson's paradox. Now, we are all concerned about our health. We are all cautious about the treatments, the medicines that we take. Okay? Now, suppose that there are two drugs. Drug A, that means medicine A, and drug B, medicine B. Okay? Which is available for one treatment. Now, it is known that different genders respond differently to these drugs, right? So, the treatment effect in terms of response is, say, out of the 10 people who were, 10 male people who were given drug A, 5 were cured. Out of 100 males who were given drug B, 38 got cured. And in the females, out of 100 females who were given drug A, 30 were found to be cured. And similarly, out of 10, only 2 were cured. So, consolidating this information, we realize that there is some glitch in this. Look carefully. Look carefully and tell me, what do you see? Okay, you cannot tell me now, so I will tell on your behalf. But please observe this. I'm giving you 2 seconds. Observe this and let me know. Is overall recovery rate not reflecting individual recovery rate in response to drug A and drug B? Now see, 40 on 100 Kevin, 40 on 110 is a better figure than 35 on 110. Simpson's paradox. So overall, we see that drug B is good, is it not? Okay, please check my statements because here you cannot respond to me. So overall, if I just look at the last row of my data set, I say that drug B will be recommended for treatment of this ailment, whatever that ailment is. Okay. However, if you look into the subdivisions of this data, if you look in this subdivision, what do you see? We found that 5 on 10 is almost 50%. And this is less than 50%. Okay. I believe all of us agree this is 50%. This is less than 50%. Okay. So on males, we see that drug A is more effective. It cures more males, right? Similarly, treatment effect in females, 30 upon 100. Can you see this? Is better than 1/5 here. 2/10 is 1/5 only. This is greater than 1/5. This ratio. Fine. Do you see the paradox? Do you see the counterintuitive statements here? If you look in the subsections, you get another result. If you look at the consolidated figure, you get another result. That means gender specific, each gender is responding better to drug A. But if you consolidate gender, you do not look at the subclassification, drug B seems to be better. Right? So, if you are the physician, whether male or female, will you prefer treatment A to B? Will you? How will you decide? So, this is thought for you today. Okay? Think about it. Now, see. Simpson's paradox. That is the first thought I gave you today. Second thought. I will speak of three friends. The friends are A, B, and C. Right? They are walking through a desert. Deserts are known to be devoid of water. There is no ready water supply in the desert. It's very scarce, right? Now, when they were traveling, they decided to carry their own bags of water. In olden days, they used to carry water in the leather packets. So, this is one such leather packet. Now, there is a relationship of jealousy, enmity, and revengeness among these friends A, B, C. Try to see what relationships. A does not like B. Okay? Sorry, C. A dislikes C. So he thinks, I will poison the water source, the water bag that C is carrying. So A has some plans, right? Devious plans, very vicious plans. So B also wants to murder C. But he did not know that A had already poured some poison in the water supply of C and it is contaminated. So B has another plan to kill and get rid of C. Without telling A, what he does is he makes a hole in the water bag which his friend C is carrying. Now see, the water was poisoned by A already, right? Now, when there is a hole made in this bag, then water drains out. So plan was to kill him. What do you think? Did B through this method saved C or did he try to kill and succeeded in killing? So the question is, who is the murderer? C eventually dies. Who is the murderer? A or B? According to some, B will be the murderer because C never drank any poison put by A. According to opposite argument, A will be the murderer because B's action had absolutely no effect on the outcome. Once the water was poisoned, then had B not, even if B had not intervened with this situation, C would have died. So these are two kinds of counterintuitive statements. Okay, these are counterintuitive statements. In this friendship paradox, we do not know who killed C. So this is your second thought for today. First thought is, which medicine will you recommend to the people for getting rid of this ailment? Second is, who killed C? Right? This is your question today. Who killed C? A or B? Right? I will repeat my arguments. The argument is because C never drank that poisoned water, A cannot be held responsible. Right? But then B dug a hole on this bag. Now they are saying that even if B had not done anything, C would have died. So who killed? Who is ultimately responsible for killing C? A or B? Some people say A, some people say B. Think about it. Okay? Now, my third argument for today. Now see, people are saying something about themselves. In my third illustration today, people will be saying something about themselves. Okay? So, the first statement, self-reference, first statement. Now see, we are saying that an individual, a human being, can perform any action. This is the statement, okay? Can perform any action. If this is true, if this statement is true, then this human being, this individual, he should be able to create a task. He can do anything, right? He can perform any action, he can do anything. So he should be able to create a task that he himself cannot perform. So if he can do anything, then he can create something that he himself cannot perform. And once this is also true, then this statement becomes false. Is it not so? Think about it. So this is self-reference paradoxes. I will take a series. So do you see that? Okay. So for example, if I say that I can create a rock which is so heavy that I cannot lift it. Now can you think about it? I can perform any action. I've created a very heavy rock which I cannot lift. So I cannot perform myself. So this becomes false. Right? So if I cannot create such a stone which I cannot lift, then my first statement is already false. If I can create a stone which I can lift and which I cannot lift, then it becomes false. If I cannot create such a stone which I cannot lift, then also it becomes false. Do you look at my argument? Okay, self-reference. So this is the first in the third series of examples, self-reference. Again, this is paradox. Okay, counterintuitive. So we have to look for mathematical reasoning here. Now the mathematical, see, my topic today is, I repeat, my topic is scientific evidence for mathematical reasoning. Today I am covering scientific evidence. I am giving you two opposite views on the reasoning. Your homework, which no one will ever ask you whether you did or not, is to resolve the issue. Two opposite views. Give your mathematical reasoning to it and resolve these issues. Simpson's paradox, friendship in the desert, self-reference about creating a very heavy stone which I cannot lift. Now next, see, this problem comes from ancient Greece. Okay, so this if you search on internet, you will find this problem from the ancient Greece. Okay, Several versions, several different stories you will find. So, on the Wikipedia also, you can go and refer. On the Wikipedia, this problem you will write and you will see. Now, see, what is it about? It is about a very famous philosopher. Nowadays, you see the good and successful professions are um, professors, doctors, engineers, astronomers, scientists, painter, archaeologist. Okay, these are all successful professions. But there was only one most respected profession in the ancient times, that of philosopher. Okay, because they just thought. They did nothing. They just sat at one place and thought and thought and thought. Fine. So what were they doing? They were weighing various reasoning options against each other all the time. If you do that at home, your parents will be very angry. What you're doing, sitting at one place since 3 days and thinking, and you're saying you're thinking, they will not accept it. But in ancient times, it was the most respected profession. Okay? So, don't do that at home, thinking for 3 straight days, saying that Ranjita ma'am had asked us to think. Okay? Fine. So, philosopher. The name of the philosopher was Protagoras. His student, this was a teacher. His student, he also became a very famous philosopher. Euthyphro. Okay? So the story about Protagoras and Euthyphro goes something like that. The teacher started teaching the student. The understanding between them was, whenever the student won his first case, first argumentative case, then he will pay his teacher. Not during the teaching time, but after he has completed his course, and then the first time he goes and wins his philosophical arguments at some platform, earns money from there, then he will pay his teacher, right? I repeat again, there is a case of philosopher handing down his knowledge to the student. The student is not paying anything at this time. Once he finishes the course, he goes on to practice the profession. The first case which he wins, from that money, he will pay his teacher. Okay? I hope I'm clear. Now, this Protagoras, the teacher, he demanded money as soon as the student finished the course. Right? The student completed his education under the guidance of teacher. And Euthyphro said, I have not yet won any case. So how can I pay you? So teacher became very angry. He filed the case in court. So Euthyphro fought his own case in court. That was his first case. Okay? At the court, the teacher argued that if the student won the case, the student has to pay the money. And if the teacher won the case, then also student has to pay, because the case is about paying the teacher. Now, do you look at the paradox? I repeat, the teacher and the student have an agreement that the first case which the student wins in court, that fees will go to the teacher towards his fees of teaching. Now, as soon as the course is finished, Protagoras, he says that now you give me my money. Otherwise, I'll go to court, and he goes to court. In the court, now see, by all means, Protagoras will get his money. Because if the student loses, even then the case is, the stake is that he should pay the money. The stake is for paying the money. So even if he pays, even if the student fails, he has to pay. But the student now argues that if he wins, then by court's decision, he will not have to pay. If the student wins by court's decision, he will not have to pay the teacher. And on the other hand, if he loses, then according to the agreement, he has not won a case. So he cannot win the case, and therefore he doesn't have to pay. Now look at the counterintuitive thing, okay? Now, which of the two men is right? The question for you today is, who is right, the teacher or the student? Do you understand the question? In the self-reference category from the ancient Greece, which of the two men is right? This is the paradox. Okay, this is from my some of my earlier class where I had taught, but I wanted to share with you this problem. It's called racing car problem. Okay, this is not a paradox. I'm bringing it in between so that I can help you resolve your paradoxes, which I have left open to you. Okay, now see, you read this. This is a simple real life situation. I just wanted to ask, is my screen still visible to all the students?
Yes, ma'am. It is well.
Okay,
It is
thank
visible.
you.
It's visible, madam. Can the size be increased?
Okay,
It's
I'll
very
check.
small
Yes,
font.
okay.
Yeah, it's fine.
Is that all right? Is it okay now?
It's okay, madam. Readable.
Yes, ma'am.
Okay, okay, thank you.
Readable, ma'am.
So these are some fun exercises which I had taught at some other place. So I'm sharing with you just to lead you to the intuitive argument. Which of the two reasonings is more correct? Okay. So I will present this racing car problem to you. Let me introduce this as the original problem. The original problem was during World War II. The Germans were very efficient in technology. So they were very scientific in temperament. They were very meticulous in their data keeping, in their inventory maintenance. So they had very high level of army tanks with them in that era. So the Allies, they didn't have it. Now, Allies wanted to know how many tanks these Germans have. So, the statisticians during that time, they devised a strategy for estimating the total number of tanks which the enemy might be having. So, that was done by using a gap estimator, GAP, gap estimator, right? Now, in the defense, if you do some research, there is a period, for example, 40 years. They don't publish this research. So this research was published in 1978 in Journal of American Statistical Association, JASA. Right? So I downloaded it from there, I read it, and then I read an illustration on that problem. So in that particular paper of JASA, they had published all the mathematical arguments why this gap estimator is a good estimator. They had shown that it had all the good statistical properties, for example, unbiased, consistent, minimum variance, and so on, right? So that paper, based on that paper, we know, we have confidence that gap estimators are good, right? So the problem was that these German tanks, when there is a fight on the battleground, these people, they would leave their tanks and go, and maybe they would die or they may flee the battlefield. So these allies, they had some tanks which they had captured from the battlefield. Now, in that battlefield, maybe let us imagine three were caught. Three tanks were caught. So each of them, as I told you, they were very meticulous with their inventory management. Each of them was numbered serially. So that number led these people, allies, to believe that all the tanks of this particular category would be numbered. Now they were interested in the highest number, the total number of tanks which were produced in this way, right? So gap estimator helped. How? That I will introduce another problem now, the racing car problem. So a latecomer to automobile race, he observes, this can be a horse race also, right? So something, you visit a scene where some events have already occurred and some are going now. So see, if each horse or each car in the race is numbered, even then some will be faster than other. So they would have already passed the point at which you are standing right now. Okay? And you're not going to stand there till the finish of race. You want to attend only 15 minutes. So during the time you... Yes?
Sir, hello, dear participants. Dear participants.
Okay, can I
Continue,
speak
ma'am.
now? Okay.
Yes, ma'am.
Okay.
Thank you,
So
ma'am. Thank you, ma'am.
during this time, these 15 minutes, you saw only 3 cars. Says they were numbered 6, 17, and 45. Now the objective is, assuming that the cars are numbered from 1 to small n, that n is unknown, you have to estimate it. Determine n, right? The alternative situation, you have a manuscript, you have a book, a very old manuscript. Only 74 pages with different numbers you can retrieve. Okay? The largest number in the sequence is 187. You want to estimate total number of pages in the book. So these are 3-4 different situations: horse race, car race, battlefield tanks, or maybe the number of total pages in a book, right? So how you can estimate the maximum from the whole? So what we do is this. I'm telling you, I'm sharing with you a scientific strategy to determine through the mathematical reasoning which is the correct statement. So if you pick the maximum of the car number which was observed in the sample as the representing maximum of the population also, then also it is correct, because you may underestimate but you will never overestimate, right? But in this, obviously the problem is of underestimation. Now if you underestimate, then what is the chance and how much of underestimation can be done? For that, I have devised this case study. Let us say that there are 5 cars in the race. I'm telling you that you have to estimate small n as 5. Okay? So I'm telling you beforehand, just so as whatever strategy formula I give you at the end, you have more faith in it. I'm telling you why it is correct. Okay? So those good properties, unbiasedness, minimum variance and consistency, I'm going to illustrate through table 1 here. So let us say that in that 15 minutes, you cited only 2 cars. At that, you do not know how many cars are there, but I know, so I'm telling you beforehand that there are 5. Now, you cited the number 1, 2 or 1, 3 or 1, 4 or 1, 5. I am reading from the first column. The first column will list all the possible pairs which could be cited if the maximum value of small n is 5. So as I said, you try to say that yes, whatever maximum I have observed, that is the value of small n. So in the second column on table 1, we have value of the maximum estimator, 2, 3, 4, whatever. Okay, from the first column, you can see which is maximum in the pair and record it in the second column. And then you see, I have devised a strategy here for the adjusted estimator. The strategy you see, pair in the first column 1, 2. Okay. Value of the estimator, each time I am saying 3 by 2 into maximum minus 1. Can you see the formula in the third column that I have devised? 3 upon 2 multiplied by maximum in the pair less 1. So that is my adjusted estimator. Okay. How we have done this? We have computed average value from column 2. So in column 2, I already have all the maximums. So for that, I have calculated the average of the maximums. Once I see that it comes out to be 4, I'm sure that any estimator which I'm developing through this strategy will never overestimate. It will underestimate but never overestimate, right? But I want that bias also, underestimation bias, to be smallest. So I just see we are averaging a group of figures and therefore of course it will be biased low. So how it will be smallest? Those who are from statistics background, they will know that this is from this knowledge expectation that the whatever is maximum will be smallest than the actual maximum, the true maximum, right? This comes from central limit theorem. Now see, the maximum could be, when you are watching a pair, the maximum could be, possible maximum could be 2, 3, 4, 5. The frequency with which it is observed, I have picked up from table 1, column 2. The frequency with which 2 is observed. It is 1. The frequency, now look at it, 3. Value 3 is repeated how many times? 2 times. Value 4. Can you just check it and see how many times 4 is repeated? So, how many times each of the possible values in table 2, column 1, how many possible times it could be repeated, I have now counted and kept in column 2. Right? So, I see that the largest value in this population is 5 and that will come from the second column. The frequency is 4 upon 1 plus 2 plus 3 plus 4. Right? In the denominator, I will write 1 plus 2 plus 3 plus 4, the total frequency. Right? So, the probability is 4 by 10. This implies that the maximum of samples is less than the population maximum. The maximum of samples which is less than population maximum is 2, 3, 4. So that is 6 upon 10. So this is what I mean by the statement just below table 2. Right? So in this, I have framed this general formula 3 upon 2 multiplied by the maximum minus 1. I am trying to explain to you how I have arrived at this formula. Right? So I am trying to be biased lowest. Fine. So now I will estimate the maximum. Okay. So how I do it? See, if I observed, for example, 2 and 4, then I know that on track there are the cars which are numbered 1 and 3. If I observe 2 and 5, then I know that on the track there are also cars which are numbered 1, 3 and 4. Right? So from what I observe, counterintuitive. So from what I observe, I can scientifically reason that these must also be present. Okay? So whatever is not cited, I can count that also within that maximum observed. And so if I see, for example, 6, 17 and 45, these numbers are observed. Then how many are not observed? 42 are not observed. So out of a total of 45, the gap estimator becomes 42 upon 3, the average number which are not observed. So this is the key to framing of the formula. 42 upon 3. Okay, so if I was there, I would have asked you whether you have understood. So here I just repeat it once more. Okay, so what I'm saying is the gap estimator is developed by estimating the number of items which I am sure are there but I have not cited. So if I have cited 3 and the maximum value is 45, that I am sure 42 I have not cited. For every 3 estimators, 42 are not cited. Now I am rephrasing my statement. For every 3 observed, 42 are not cited. So the average gap estimator is 14. That means for every 1 cited, 14 are not cited. Right? So which means above 45, there should be an average gap of 14. So I will add this average gap to the maximum and get the value as 59. So this is how I had framed my formula. Right? So look at this. 45 plus 45 is the maximum value. So you see I was already all the time adding maximum value. 2, 3 in the third column. Just see I am just multiplying by the maximum value. 2, 3, 4 just before the minus sign. These are all maximum values. Okay. And then yes, you have understood correctly. That is the gap estimator. So whatever I have not observed is 45 minus 3. So on an average, per observation, what I have not observed is 45 minus 3 upon 3. So in other words, you see, I have now devised this formula. Please look at this carefully. All of you are mathematics background students, and because I am not there, I cannot explain it further. If you wish, you can take a screenshot of this. You can take a picture of this screen if you want to learn how to frame a formula for the gap estimator. And in your small birthday celebrations and other things also, you can have this kind of a game. Right? So this, I just want to share this formula with you. So you see, ultimately it comes out to be capital M, the maximum value of the population, is equal to small m multiplied by k plus 1 upon k. Right? K is whatever you have observed. 3 you have observed. So 3 plus 1 upon 3. And always less 1, minus 1. So that is, this was, I have written as in the end, then this was actually used in World War II by Americans, by the Allies, and this was published about 40 years later. I'm skipping the second one. I'm doing the third one with you because I want to ultimately go back to my paradoxes. So this is how I told you scientific reasoning is not very difficult. It is just at the end of my talk, who will go in which direction depends on your own potential and efforts. Okay. Now I am sharing, many of you may not have heard the term geometric probability. Whatever you have known about probability is what I did earlier, the number of favorable events in the numerator and the total number of exhaustive events in the denominator. That is called relative frequency. Most of you would have done that so far. Some of you would have known geometric probability, especially the statistics student would know, but for the others, this would be a new term. No problem. What I'm doing is, I am trying to tell you about a paradox through probabilities, and in this case, I'm bringing out the scientific proof in the form of geometry. So I will show the geometry of probability to you rather than taking the relative frequency concept. Okay. So you just read what I have written as a problem. I'm giving you 2 seconds. Now see, I have a basket in which intentionally, I am very clever, I'm a statistician, intentionally I placed 2 marbles of one color and 1 marble of another color. In total, we have 3 marbles. So if I put 3 marbles at 3 points on a page and then join them using a straight line each, I will get figure 1a. Can you see? G represents the green marble, R represents the red marbles. Okay, I have 2 red marbles, 1 green marble. So this is the geometry of the situation, figure 1a. Okay, now the rules also I have framed. I have said, if each of us will, or any of us will pick up 2 marbles without looking at it, close your eyes, pick up any 2 marbles from the basket. My rules are, if the colors match, then I will do the cooking. Otherwise, my friend will do the cooking. Okay? So every day, my friend who's not from statistics, she ends up doing the cooking. She's very angry with me. Okay? Now, I will explain to you why it will happen. Okay? So, see. Figure 1a. Look at the sides. I told you I will look at the geometry of the probability rather than the relative frequency value of the probability. Okay. So, we will just join GR points. We see that the side which is called GR, that means side connecting different colors, are more, and side connecting similar colors are less. Fine. So you understand why I framed the rule. It was a biased rule. 2/3 of the time, 2 out of 3 sides, 2/3 of the time, the colors will not match. Only 1/3 of the time, the colors will match. And this is why my friend ends up doing all the cooking most of the time. It is not a fair rule. The game is not fair one. So my friend says, okay, this is the problem with some rule. Okay, she is also from mathematics, if not statistics. He says there are too few green color. So let us put equal number of reds and greens. Now see, she is looking at the geometry. She is not looking at the rule. The rule is, if the colors match, only then I will do the cooking. In figure 1b, look at figure 1b. Now what? Out of 4, how many are similar and how many are in figure? 1B, how many are similar and how many are different colored? Look at this, record for yourself. If you wish, you can have a picture of this page also. I'm giving you some food for thinking scientifically through these sessions that I'm having you with today. So in this situation, in figure 1B, GGRR, colors match. Okay? GR, and then you create two diagonals also. The pairing can be for the two vertices also. Is that not so? Because it is possible that if you number these red marbles, so one is R1, one is R2. So pairing can be G1R1 or G1R2. So I have not created diagonals in figure 1B. You create diagonals also, because pairing can be, you are picking randomly, pairing can be done in that way also. G1R1, G1R2, G2R1, G2R2, right? You end up numbering them also, or you just draw the diagonals. So what happens? Now you have 6 sides, 6 lines, and in that only 2 have same colors. Can you see? 2 by 6. I am cooking only 2 times out of 6. And my friend now is increased. She is doing 4 by 6. So what happened was, adding one green marble, it did not balance out the work distribution. In fact, it was made more unequal. Right? So I am giving you, I repeat, scientific thinking today. By making the marbles equal does not solve my problem. I have seen through this geometry. Okay? In figure 1B, please draw the diagonals. Now look what should be the right choice. If you have, I have given here in table 3, first column R, red marbles. The number of red marbles I can keep. Each row represents different combinations of the count of red marble and the count of green marble. Okay? The third column gives me the total number of marbles of all the colors. Okay? I repeat, the rows represent a number of colors and the last column represents the total of individual colored marbles. I have 4 rows here, therefore 4 cases have been illustrated by me. The combinations that I suggest is, you keep 3, 1, 6, 3, 10, 6, 15, 10. Where these numbers come from, I will tell you. Okay? So, these are called triangular numbers. 1, 3, 6, 10. See. 1, 3, 6, 10. Can you see the green column, G column, table 3, column 2. 1, 3, 6, 10. Okay? These are called triangular numbers. So the triangular numbers, how they arise? Just consecutively natural numbers, keep on adding them by pair. Okay? 1 plus 2, it becomes 3. So now you have 1 and 3. I have tried to illustrate it geometrically also using these small red dots. Is that clear now? 1 plus 2 will give me 3. 1 plus 2 plus 3 will give me 6. 1 plus 2 plus 3 plus 4 will give me 10. Can you see progression of the triangle in this picture? Is it clear? Is it visible? You can continue to add more columns there. Okay? So this is the trick. The reasoning is normally not so easy. My friend said, okay, make the number of red and green marbles equal. And it was still further unbalanced. So sometimes solutions are achieved through mathematical arguments called the scientific reasoning, and that here in this case is obtained, achieved by the fair game is achieved by the triangular numbers where you get equilateral triangles. Okay. So I have given why it should be a fair game. Again, this is a research paper and the result was there. I have simplified it in terms of the marbles. So this compilation, these two examples which I have shared with you today, I'm just trying to make the computations easy and to do away the fear of statistics. So this was the presentation which I wanted to share with you today. I will come back to my screen where I will again share with you some writings. Okay, so we come back to the paradoxes. तो 5% बैटरी है चलेगा 15 मिनट और आराम से Okay, so uh, now see, these are 10 keys here, and out of these, you have to tell in which attempt. See, that person who's drunkard, he does not have logic at that time. He cannot choose through logic. So he's just selecting the keys randomly. Okay, randomly he will pick up a key and try to open the lock. You have to tell me in which attempt the probability of opening this lock is highest. This is a paradox. Probability of opening the lock is highest in the first attempt actually. But I'm giving you the answer. But you have to think and tell me why. Why I'm telling you that first attempt, if he cannot open, he will keep on lingering and lingering and lingering. Okay? Highest probability by chance, by random selection is the first event. Okay? So you think about this, another thing for you to think over.
madam.
Oh, sorry, I was mute on this time. I'm so sorry for this.
Okay,
Okay,
madam.
I will
Okay.
repeat.
Okay,
Uh,
madam. Okay.
the last session, I will end by helping you understand the dilemmas which people have while making inferential reasonings, right? So these small sentences I have compiled from a newspaper in 2017-18. Okay, as I told you, this was a very sudden talk for me. I got only 10 minutes to prepare, but I'm thankful to Sir Gandhi sir, who could arrange this small meeting for me with you, so that I can communicate. And therefore I decided on just speaking about pieces of different knowledge that I can with you. So this is, you see, breast cancer rate in the United Kingdom are more than 4 times higher than in the Eastern Africa. So does it mean that it's doesn't it look very awkward to you that Britain is such a successful economy, and how come they have this more death rates? They have higher facilities, health facilities. They have better trained doctors. They have the population who is more educated and more aware and more open to seeking help from hospitals and doctors. Hmm? So, what is wrong in this statement? This statement is correct. World Cancer Research Fund has made a statement based on data. But what could be the glitch in this interpretation? See, number one, you have to think like that. Intuitive thinking. I'm trying to train you today. Number one, in UK, more people will go to the hospital. In Africa, less people will have access to the hospital. Even those who have access will not go there for religious purpose, right? Because they are not so educated, they are not so aware, and then access is also limited. So the cancer diagnosis, treatment, and cure, right, all is higher in UK. I'm helping you, I'm trying to help you through that first problem that I posed today, right? Simpson's paradox. So more than 4 times higher, only because more cases are reported and recorded there. Africa has a problem of not reporting, under-reporting, and not taking treatments, or treatment not being available to them. Okay, so this does not mean, if you read this kind of a statement, it does not mean that UK is very bad in context of cure of cancer, right? Or it has a worse mortality rate from cancer than compared to the Eastern African countries. You cannot take that inference here. Okay. Now, second sentence was, death rates from breast cancer have fallen dramatically in UK than in other European countries. Now you will say that, okay, all of them are almost equally educated, almost equal access to healthcare facilities. But how come in UK it has fallen more? Actually, in UK, thus in the beginning, thus you read this. England began with the worst death rate in the beginning, and then compared to their own, because this is a relative statement, compared to their own situation, they have improved. So see, the values are also very close. Okay, from in 100,000 English women, 42 used to die in 1989 and 30 in the other European countries, right? And later on, it came out to be more. So this is kind of a thing which I want you to read carefully. I will stop for 2 seconds. I want you to learn the logic here. Oh, I'm sorry. Okay, I think I lost that one. Okay, this again seems to be some problem. Okay, let it be. I have to open it. Yes, I want you to read this carefully. To develop your own intuitive logic. Okay, so now I want to do in the. Oh, I think my time is over. Is my time over, sir?
Ma'am?
Is my time over or can I continue?
No problem for your willing the ma'am. No problem, ma'am.
Okay, 5 minutes I'll take more so
No
that
problem.
I
Okay,
finish
ma'am.
the talk. Okay, thank you
Thank you.
for this.
Thank you, ma'am.
Okay, see, uh, just look at this picture. Okay, the first picture is on the right hand side top. If you look at such a figure, you will know that we cannot untangle it. Right? We cannot untangle it. They are in it together. But how we can untangle it if this object is very elastic? Then you can unchain these two loops. And how you do it, look at the arrow, follow the arrow. This you will not get anywhere. If you want, you can take a picture of this again. So if somebody shows you such a figure in plastic or steel, then you cannot unchain it. But this you can do if it is made of a very highly elastic material. How? The arrows will lead you to it. This is also a paradox and it's called pretzel transformation puzzle. Okay. If you wish, you can take a picture from this. I have taken it from a very rare book I found somewhere. And lastly, I will resolve the paradox of the drunken man. So there are 10 keys on his ring, right? So he has to pull a ring randomly and try to open the door. Okay, so the number of trials obviously will be 1, 2, 3, 4, 150, whatever. Because repeatability is required. He is not using his senses, right? So the most likely value is 1 because those who have done statistics will realize that probability of getting the correct key is 1 upon n, right? In the second trial, 1 upon n. Third trial, 1 upon n. So you just keep on, when you have multiple events. When you have multiple events, then you multiply all the probabilities. So say 1 upon 6 multiplied by 1 upon 6 or 1 upon 10 multiplied by 1 upon 10. So product is always smaller. This is what I have written here. That probability of picking up the correct key in the first trial is higher. And it goes on reducing as we keep on increasing the number of trials. So this is the paradox. This drunken man will most likely get the right key in the first attempt. So these were some paradoxes which I just shared with you today, and it could have been a more organized talk, but I hope I have communicated something to you. Thank you for listening to me at this platform today. Thank you, the resource persons and the organizers, for giving me this opportunity today. Thank you. With this, I finish my talk.
Thank you, ma'am. I am very happy, ma'am. So you are accepting my invitation within 20 minutes. So immediately accepting my invitation. Once again, I am thanks to so much for your supporting and my consideration of invitation, ma'am.
Thank you, sir, for this opportunity. And it was a pleasure, and it was an honor to be connected with so many people and at a different place in these difficult times. Thank you for giving me that opportunity, sir. And I hope that the students who heard me have made this time useful for themselves. I hope I was able to communicate and bring some kind of thoughts to the new generation. Thank you, sir.
Ma'am, can you please come video, ma'am?
I don't know. Your option is not allowing me to open video. I've tried it many times, sir. I am blocked. I think you have to open it.
No problem, ma'am. You close, ma'am, presentation portion, ma'am.
Okay, okay,
So
okay.
immediately open
Okay,
with
okay.
the video, ma'am.
Okay, sir. Okay.
Okay, ma'am. வந்துட்டாங்களாப்பா?
No, sir, it is not available. I cannot switch on my video, sir.
Okay.
Madam, you press that stop presenting button. Then
Yes,
you
ma'am. That
try
is
to turn on the
Okay,
video.
okay, sir.
the
Okay,
presenting
sir.
stop the portion is
Stop
enough, ma'am.
presenting.
Immediately open the video, ma'am.
Okay, sir. Stop presenting. Stop.
Madam, press on stop presenting.
PDF காப்பி பண்ணிக்கலாமா சார்?
Yeah, now you try to turn on your video.
Okay, sir.
Yeah.
I don't know.
Yes, ma'am. Thank you. I have talk on as this is
Okay.
the formal. We are working for a government university, ma'am. They take recruit for some process, ma'am.
Okay, sir. Can you? Okay, I think you have to take my video. This is why.
Okay, ma'am. Okay, ma'am.
Okay.
Participants, feel free. We discuss with the ma'am. Depends upon.
Yes, yes. If you want to ask any questions, you can ask.
Hello, madam. Good afternoon. Can you hear me, ma'am? I think her battery has gone down.
Ma'am, audible, not audible, ma'am, for your voice, ma'am. I think, sir, ma'am system is in a, I think, hang maybe.
Yeah,
Possibly,
battery
sir.
was very low.
Yeah, yes, sir, sir.
That's the reason. It's okay.
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 So, tomorrow is generally for regular time, sir. Tomorrow for 10 to maybe join 10:15. That is very nice. Okay.
Okay, sorry, I was disconnected in between.
Ah,
Uh,
okay.
okay. If my
No
role
problem.
is over, I can leave, and if you have questions, please ask me.
Okay, ma'am. Thank you, ma'am. Once again, thank you for your presenting session, ma'am. So,
Thank you so much.
great pleasure too, ma'am. It's a welcome, my pleasure, ma'am. Okay, ma'am. Thank you, ma'am.
Thank
Thank
you.
you very much,
Thank
ma'am.
you.
Ah, okay. Okay, dear participants, already I post the feedback form. Kindly fill the feedback form. Tomorrow we'll start 10 o'clock. Sir, okay. Yes, sir.